Let's say question 1. Ask you which compound is a strong electrolyte. A. Water. B. KOH. C. Acetic acid. D. C2H6O. I give you name is ethanol. Which one is a strong electrolyte? Garrett, Winchester. Do you know which one is a strong electrolyte? B. B, yeah. B. Strong electrolyte. Why we select B? B is a strong base. Strong electrolyte could be strong base, like a KOH or NaOH, anyway, from group 1A. Or some of these from group 2A, BaOH2 or SrOH2. This is strong base. Or strong acid, like HCl or H2SO4 or HNO3. So strong acid, strong base. Or soluble salt, right? So among these, only this strong base is strong electrolyte, and water is a very weak electrolyte. We give example. Use water as an example during the class. And this, we give this as an example as a weak acid, acetic acid. And this is ethanol, alcohol. It's organic compound. It's a non-electrolyte. So your choice only B. Question 2 asks you which one is a non-electrolyte. A, NAF, B, HNO3, C, CHCOOH, CH3COOH. This is the same as question 1. D, C6H12O6, and give you name is glucose, which is sugar. It's organic compound. It's non-electrolyte. The only choice is non-electrolyte. The other is a soluble compound, sodium there, right? Soluble ionic compound, strong electrolyte. This is strong acid, strong electrolyte. This is weak acid, weak electrolyte. Right? 3. Ask you for this reaction. Which one is the oxidizing agent? Oxidizing agent. Only 2 choice here, right? This is not a clue. Oxidizing agent, only reactant. Okay, so either this or this. So A, oxygen. B, strontium. Then according to this explanation, you don't need to care about the C and D, right? Because only this or this. C and D not related. You don't need to care. Okay. Which one is oxidizing agent? Oxygen, yes, oxygen. Oxidizing agent, the name comes from oxygen. The oxidizing agent must be non-metal. Right? Oxidizing agent must be either non-metal or metal ion could be. Reducing agent always metal. If ask you which one is the reducing agent, this strontium is a metal. Ask you which one is the oxidizing agent, either non-metal or a metal ion. Here, do we have a metal ion? Yes, strontium ion. Here is a metal ion, but this is a product. It's not a reactant, so not included there. So only these two choices. The thing is the oxidizing agent, which is non-metal. Hey. Or ask you identify major ions. Major ions in aqueous solution of potassium sulfate. Okay. This is a little bit harder. Okay. But we give examples, more than one example for this type of question. So this aqueous solution is this ionic compound? Yes, potassium ion is a metal ion, and the sulfate is an ion. Break down into ions. What is the charge for SO4? Clearly negative 2, because potassium group 1A is positive 1, and you have 2 potassium, then positive 2, then sulfate must be negative 2. The question is, you need to move this 2 in front. Initially, this 2 is 2 potassium bound with 1 sulfate. Now break down into individual ions, then this 2 must be in front, no more be here. Then what is a major ion? Of course, it's just potassium ion and sulfate ion. Okay. So your choice is B, potassium ion and sulfate ion. The major ion is potassium and sulfate. Potassium ion and sulfate ion. The choice is B. Okay. 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 Then question 5. You ready? If I write here. Question 5 asks you what is the concentration of NaOH if 33 milliliter of NaOH is needed to neutralize 42 milliliter of 0.23 molar HCl. Ask you what is the concentration of NaOH? Okay. So if 33 milliliter of this NaOH is needed to neutralize 42 milliliter of 0.23 molar HCl, ask you what is the concentration of NaOH? Then you need to write the balanced equation of the reaction between HCl and NaOH. What is the reaction is? Acid base, right? Acid base reaction produce salt and water, right? Water comes from hydrogen ion and hydroxide ion. So you just keep in mind of this, then you easily balance the equation. 1 hydrogen ion, 1 hydroxide ion, then produce 1 water. Then Na Bind with sea air is a salt. This air what is known as table salt, right? Is this balanced? Yes, it's balanced. Now we just list the condition tell us. NaOH volume is 33 milliliter. Concentration we don't know. We want to figure out, right? Volume times concentration is what? Mole or millimole. If we use milliliter, then will be millimole, right? Concentration. Okay. We use this formula in the bracket. Right? Symbol is capitalized M. Define as moles over liter. Liter is solution. Right? So if we know the molarity concentration together with the volume, which is liter, then you get more, right? Molarity times liter is more. If this is milliliter, then this is millimole. Right? So milliliter times molarity is millimole. HCl volume 42 milliliter. Concentration 0.23 molar. So milliliter times molar. Molarity is a millimole. So millimole, then millimole relationship, right? What is a mole relationship here? No number means 1, right? Their mole ratio is 1 to 1. This tells us the moles of NaOH equal to moles of HCl, right? Then millimole equal to millimole, 1 to 1 ratio. So for this balanced equation, this tells us 33 milliliter times molarity of NaOH should equal to 42 milliliter times 0.23 molarity from HCl, right? Based on this balanced equation. So can you solve this equation? Find NaOH concentration? Yes. Both sides divided by 33, right? This is a very simple math. Milliliter concert, leftover molarity. This is your answer should be 0.2927. So you selected the choice is B. Okay. So you select the choice B. Now recording video. So you select the choice is B. 0.2927 molar. Okay. You're okay with this? Then question 6. Ask you how many grams of Kf needed to make 500 milliliter of 0.5 molar Kf solution. Ask you how many grams of Kf. This is mass. We need to figure out how many grams of Kf needed, which is mass. Here tell us concentration together with volume, what we can calculate. Yes. Concentration together with volume, we can calculate the moles. Then from moles, can we calculate mass? Yes, I always write in this place. Mass, lowercase m, to mole, and is mass divided by molar mass, right? When we get moles from molarity, liter, you get moles, then we want to get back the mass will be mole multiplied by molar mass. Molar mass, take a look at the periodic table. We can figure out molar mass, right? So molarity times volume is more. Kf equal to molarity 0.5. In order to get more, the volume must be in liter, right? And here is milliliter. So milliliter you need to convert to liter. Right, molarity, milliliter converted to liter, so by divided by 1,000. Then liter times molarity is more. Right, 125 molar. Then more multiplied by molar mass. So mass equal to more multiplied by molar mass. What is molar mass? Take a look at periodic table. Kf. K molar mass is 39.0983. Then simply is 39.01. F 18.998. Hey, that's just 19. Okay. Use your calculator. You can easily get this number is 14.53 grams. So you select the choice is D. Seven. Question 7. A gravimetric analysis is done according to the chemical equation. Barium chloride. Let me give more space. We can, because this still multiple choice, we can leave some space to fill in our answer. So balance the equation is barium chloride react with sodium sulfate produce barium sulfate solid plus sodium chloride. If 0.5358 gram barium sulfate, 0.5358 gram barium sulfate is collected as precipitate, solid is precipitate. When barium chloride solution is reacted with excess, so tell you this is excess. That means this is limiting, right? Limiting means this all react. Okay? So this all becomes barium sulfate. We want to determine how much barium chloride is there. Of course, you need to force this completely react compared to barium sulfate. Ask you how many grams of barium sulfate was percent initially. Ask you mass of barium sulfate. Here you mass of barium sulfate collect. Also you mass of barium chloride initial percent. And here even tell you molar mass of barium sulfate. Molar mass is barium sulfate is 233.3. And the molar mass of barium chloride is 208.2. How to solve this problem? Okay. Balance the equation already there. This balance the equation tells us more ratio 1 to 1, right? No number means 1. In order to form 1 more barium sulfate, you must have 1 more barium chloride, right? In order to form 1 more barium sulfate, you must have 1 more barium chloride. This is the balance the equation tells us. New number means 1. Right? Then this is the mass. And we need to convert to mole. This is mole ratio. So mass, no, sorry, mass convert to mole is mass divided by molar mass. Right? So mass divided by molar mass. This is a mole of barium sulfate. And this mole barium sulfate, according to this balance equation, so mole ratio is 1 to 1. This means this also is moles of barium chloride. So more barium sulfate equals to 0.5358 divided by 233.3. Right? This also equals to moles of barium chloride based on the balanced equation. Can you understand this? Because 1 more barium sulfate must have 1 more barium chloride. Right? Then we have more barium chloride. Can we convert it back to mass? More multiplied by molar mass. Right? So mass of barium chloride will equal to more of barium chloride times molar mass of barium chloride. Molar mass of barium chloride is 208.2. So use your calculator. You can easily get this number is 0.4782 gram. So you select the choice is B. Okay. We need a space here. Are you okay with this? It's worth 3 points. Most of you get a loss is question 8. This one is not a multiple choice. You need to work. A, ask you balance this equation. Silver nitrate react with sodium sulfate produce silver sulfate precipitate and sodium nitrate. Balance the equation. Since there is 2 here, right? Then clearly you need to put 2 in front. Okay, balance the equation. You can only change the number in front of the formula. You cannot change this number, this subscript number. This time we have at least 2 students change this subscript number. You cannot do that way. Listen carefully. If you change this number, then substance changed. This is not a balanced equation. This is you correct the reaction. Actually will not happen. Balance equation only change number in front of each formula. This means change the quantity more. So 2 silver, they must have 2 silver here. So 2 times 8 silver. So silver balanced. What else we need? Since 2 silver we give 2 here, this becomes 2 silver and 2 nitrate. 2 nitrate react with 2 sodium will produce 2 sodium nitrate. Now rest is SO4. It's balanced. It's easy. You only give 2. It's balanced. Then B. As you write total ionic equations. Total ionic equations, that means break down a soluble ionic compound into cation and anion. But be careful if this is solid, keep the formula. If you break down a solid into ions, then you don't have any credit for that. Okay. Soluble salt, right? So break down into ions. 2 silver iron, 2 nitrate iron. Be careful, this is sodium sulfate. 2 sodium bind together with 1 sulfate. No breakdown because it's soluble into individual ions. Then you need to move this 2 to in front. This 2 must be in front of sodium ion. Sodium ion. And sulfate on iron. Whenever you say S, this represents a solid, precipitate. Solid, we call it precipitate. So keep this formula, don't break down it. Otherwise, you lose all point for a second. For this, okay. How about this? Okay, aqueous solution, right? Break down into cation and anion. Cation is 2 sodium. Anion 2 nitrate. This is total ionic equations. Then C also you write net ionic equation. Then you just take a look which ion show up in both sides. That is spectator ion. Cancel the spectator ion. The rest is a net ionic equation. Which ion show up in both sides? Clearly sodium the nitrate ion, right? Both sides you have nitrate ion. And both sides you have sodium ion. The rest is only between silver iron and sulfate ion. Produce silver sulfate, right? Silver ion with sulfate on iron. Produce silver sulfate solid. Are you okay? Okay. And this time, I give you a solubility rule, the table. So this help you right there. Okay. And actually, whenever give you molecular formulas equations, this is already labeled there, solid. And most of the net ion equation is from this iron, silver iron, and the sulfate ion. This is net ion equation. The rest all cancel. Okay with this? Then question 9. Also, you give product for this reaction is between sodium hydroxide and nitric acid. Acid base. Acid base reaction produce what? Salt and water. Water comes from hydrogen ion, hydroxide ion. The rest is salt. So, water is liquid. Water is not aqueous. Okay. Other substance dissolved in water we call aqueous solution. Water itself is a liquid air. Water itself is solvent, right? While the rest is sodium bind with, the reaction is rearrangement, right? Reaction is either combination, 2 becomes 1, or 3 becomes 1, or separation, the 1 breakdown itself becomes 2 or 3, or even 4 possibly, or rearrangement, right? Rearrangement. So this is sodium nitrate. So this will be aqueous or solid. I give you a solubility rule table. Any compound have sodium ion there must be soluble. Any compound have nitrate there always soluble. So yes, cut iron and iron tell you this is a soluble salt. For this one, we have several weird answers. Okay, this is the only correct answer. All others are not correct. Okay. Include some students write this. This is not the formula for water, even though we have 2H, 1O there. But the water must be in this formula, H2O, not HOH. For others, it's really weird. O3 or HO, or even some students write HO. This is all wrong. Okay. This is a very simple reaction. This is acid-base reaction. One hydrogen ion, one hydroxide ion. Cannot be simpler than this. Hey, ask you oxidation number for each of the following underlined atom. KMN4. What is oxidation number for Mn? Hey, potassium from group 1A, always positive 1, right? No exception. Mn, we want to figure out. O, oxygen, normally -2, right? You have 4 oxygen, so -2 times 4. Powder, no charge, 0. Solve this equation, Mn is 7, right? P, F4, oxidation number for P. Okay. You don't know what is the P. And you have 5 fluorine. Here is fluoride. Fluorine in compound always -1, right? Always -1. Fluorine group 7A. Fluorine always -1. The rest could vary. Chlorine, bromine, iodine could have several different oxidation numbers, but fluorine always -1 is a compound. 5 times -1 is 0. Why 0? Charge. Solve this equation. 4 and 5. Right? And how about this? Sodium carbonate for copper. Sodium group 1A, always positive 1. Right? Carbon we want to figure out. And oxygen -2. Equal to what? No charge, 0, right? Solve this equation. Must be 4. How about this? Oxygen molecular. What is the oxidation number for oxygen molecular? 0. It's a free element. Free element. Oxidation number is 0. So O2 or Br2 or N2 or S8, as long as it's free element, then always 0. Do you have other questions for this quiz? No? No, we have only 8 minutes left. Okay.